from the final exam practice? 28, 1, 10. Really? 3 and 2 and 4? 27 and 8? Okay, we already said that. Really? Wow. Okay, you guys, so we're just going to spend the whole hour just going over these questions. Is that okay with you?
Yeah.
Okay. All right, so let's start with number 1. Okay. Huh? Oh, which one? 17. Okay. All right, so number 1. Again, I told you to do it on your own sheet of paper. I said to do it on your own sheet of paper so that you have space. But here we go. What is x to the 5, the cubed root of x to the 5th? It's x to the 5th, but what is the cubed root? It's the 1/3 exponent, right? So this is x to the 5 over 3. Do you guys see that? Times, what's y? Square root of y. It's y to the... What's the square root as an exponent? It's 1/2, right? Do you guys understand that the nth root of x is x to the 1 over n? So x to the square root is x to the 1 over 2. X to the cubed root is x to the 1 over 3, like that. So since this was the third root, it was over 3. Since this is the square root, it's over 2. But we're going to do that to the 7th power, okay, times y to the -3, all over x to the 3/4. Okay? So let's simplify this a little bit. I'm going to bring this down over here. By the way, I hope you guys read my message. It's not multiple choice. This one's a constructed response where you have to supply your own answer. These are all the possible right answers. There's many more. No. It says a constructed response. You supply it. Okay? So, okay, let's combine these. X to the 5 over 3, okay, is over x to the 3 over 4. Now, what is y to the 1/2 to the 7th? What do you do with these exponents? We multiply them. What's 1/2 times 7? 7 over 2, right? And then this is y to the -3rd. Okay. What do we do? How do we combine these? Stop. Okay. What can I do with these? They have the same base, so what can I do? The exponents, I'm actually just going to add them, right? What's 7 over 2 plus -3? Well, if you get a common denominator, well, some of you guys might know half of 7 is 3.5, and 3.5 minus 3 is 0.5, so it should be 1/2. But let's just make sure, okay? So if I make a common denominator, it's going to be 3 times 2, which is 6. 7 over 2 minus 6 over 2 is what? 1 over 2, okay? And then this is, okay, now what do I do with this? What can I do if you're dividing two exponents with the same base? We could subtract. So what is 5 over 3 minus 3 over 4? This is my scratch work on the side. Make a common denominator. What is our common denominator? 12, right? So how do I get 5 over 3 to become over 12? By multiplying top and bottom by 4. So that's going to be 20. How do I get 3 over 4 to have a 12 denominator? By multiplying top and bottom by 3. So it's 9. So 20 minus 9 twelfths. 20 twelfths minus 9 twelfths is 11 over 12. And there's my answer. So I could write it like this. If you wrote it like this, that's okay. If you wrote it like this, that's okay. If you wrote it like this, that's okay. They're all correct. Okay? If it's like this, yes, you write it yourself. If it's constructed response. Okay? Yes? Any questions on this one? So was the tricky part knowing how to do this? Yeah, so it's x to the 5th power. Another way to see this is x to the 5th power, but all of that to the 3rd root. So it's really x to the 5th power to the 1/3 power. And that is 5/3, right? You see that? Okay, so that was number 1. Now we're going to do number 2. I wish I could zoom in a little bit. That's a little better. Okay, for homework question, Linda's asked to rewrite the expression that in the form x to the k. What does that mean, x to the k? Basically, you have to rewrite it, simplify it, so it's just 1x to 1 exponent. So I have to kind of simplify the exponents. Linda claims that the value of k is 9, since 3 times 1 times 2 to the 2nd power is 3 squared, which equals 9. Is she correct or no? What do you guys think? Is she correct? Let me rewrite it. Okay, there's 2 ways to do it. What is one way that you can think of? You guys want to distribute that too? Yeah. Okay, so then it's going to be x to the 6 times x squared, right? Because this is an invisible one. So it's going to be what? Is that 9? Yeah, if there's x times x times x times x times x times 6 x's times x times x, in the end you have x times x times x times 8 of them, right? Okay, so what is my k? Because it has to be x to the k. If it's x to the 8 is equals x to the k, what is your k? So 8 equals k. So you would put 8 in this box, okay? Another way I could do it is I could have simplified the inside first. What's x to the 3rd times x? 4. X to the 4th. And then when you square that, x to the 8th. So either way you cut the cookie, it crumbles. Just kidding. Just kidding. Alright, so that's number 2. Alright, number 3. Alright. This is an equation, okay? They want to know what does x have to be for this to be true. So basically they took this and they simplified it. So how do I simplify this left part right here? No. You have the same base, 7, and then you're dividing, so what do? It's 7 to the, subtract the exponents, 3/4 minus x over 8, right? That's the left side. What is the right side? I rewrite this as an exponent. It's 7 to what power? 1 over 8. You see that? Because it's an 8th root, so it's 7 to the 1/8. So if 7 to the that equals 7 to the this, then that equals this, ¿que no? You see that? So that must mean that this guy equals that guy. So let's take that over here. If 3 over 4 minus x over 8 equals 1 over 8, how did we subtract those? You had to have the common denominator, right? So it's really 6 over 8 minus x over 8 equals 1 over 8. Can I multiply everything by 8? Okay, fine. If that bothers you. 6 over 8 minus x over 8 equals 1. That means 6 minus 8 has to equal 1, ¿que no? 6 minus what equals 1? 5. So then x was 5. Okay? Now, just because you see me do it and you get it, does that mean you know it for sure? You gotta practice it. And you guys know these were on the RMPs, so I would go back to my RMPs a little bit and study them. Or you could always go, just Google like rational exponents, and they'll give you stuff too. Okay. Number 4, which one is equivalent to this? Select all. That means if you don't say all the answers, you're gonna get it wrong. Okay? So let's see. How can I factor this anyway? Do you guys notice how it looks like a regular standard x squared plus 8x minus 9? You guys know how to factor that, right? 8x squared. Would you guys know how to factor this? It looks just like that, except it's not 8 squared, it's 8x to the 4th, and it's x squared, so these guys got doubled, yeah? So the thing is, if you know how to do factoring by grouping, that's why I like factoring by grouping than all the other like Mickey Mouse tricks. Okay, this is what I would do. So 1 times negative 9 is negative 9. I have 8 in the middle. What two numbers add up to 8 but multiply to negative 9? 9 and negative 1, right? So what I'm going to do is I'm going to split the middle, the 8x squared. Okay, so it's x to the 4th minus 8x squared minus, wait, is it minus or plus? It's plus, right?
Yeah.
But I'm going to split this 8x squared into what? 8x squared is really 9x squared from here minus 1x squared. You see that? You guys see how 9x squared minus x squared equals 8x squared? And I got this 9 and the 1 from here. Yeah? But everything else stays the same. Do you agree that I didn't really change anything? You don't agree? The only thing I changed was this, but this is the same, right? Now that I broke them up, first of all, can I make this a plus negative? Can I group them like this? You know what, in the end, you can, but in the end, it's going to be the same. So yeah, if you group it, maybe that's better. But let's take this out, x squared. What's left here if I take out x squared? X squared plus 9. If I take out a negative 1 from here, I have x squared plus 9. Hey, what do they both have? X squared plus 9. So can I factor that out? Okay. By the way, your test is going to have a lot of difference of squares, so make sure you know difference of squares. Okay, if I factor out x squared plus 9, what's left here? X squared, and what's left here? Minus 1. Okay, is this a difference of squares, the first one? Why? X squared is a square, 9 is 3 squared, but is it a difference?
Hold on.
It's a sum, right? So that's not a difference of squares. Can I factor that? No. You cannot. That stays. Is this a difference of squares? Why? Because x squared is x squared, and 1 is what squared? 1 squared, and this is a difference. So what is it? X plus 1 times x minus 1. See, this one factors to this. The other one, you can't factor it. Yes. This is a difference of squares. This is a sum of squares. Sum of squares don't factor. Difference of squares does. So now it's fully factored. Yes? Okay. Now that it's fully factored, let's see which answers apply. Which one is the exact one that we just factored? Which letter? A, B, C, or D? C. So C is right. Okay. What about D? Isn't D what we got before the last step? It's just they just didn't factor the difference of squares. They left it. But that's still true, right? It didn't say which one is fully factored. It just says which one is equivalent. Right? So that one's right. What about B? Wait, what happens if, what's x squared? Squared. So it's just going to be x to the 4th plus 8x squared minus 9. Is that the same thing as my original? Yeah. So that's true. Huh? What about A? Why not? Where did the x plus 3, x minus 3 come from? They thought you could factor this, but can you? No, so that one was wrong. So the answers are only B, C, and D. Okay?
The difference of
Yes. So make sure you know how the difference of squares. That's difference of squares means you have two squares, like a squared and b squared, but the difference means you subtract them. How do I subtract two difference of squares? How do I factor a difference of squares? That equals a plus b times a minus b. Okay? Let me ask you guys another an example. What if I ask you for in red. Let's see. R squared S squared minus 9t to the 4th. Woo! That's fancy. Can I factor that?
Yeah.
Well, is this a perfect square?
Yeah.
Is this a perfect square?
Yeah.
Are they being subtracted?
Yeah.
So we can factor it. What is being squared here? Yeah, because rs squared is r squared s squared, right? What is being squared here? Well, what squared is 9? And what squared is t to the 4th? Yeah, you see that? So it's rs squared minus 3t squared squared. You see how that's equivalent? So then what's going to be here? It's going to be something plus something times something minus something. What's here? rs plus 3t squared. And here it's rs minus 3t squared. You see how that works? Difference of perfect squares? Okay, remember that. Wink, wink. Alright. Nobody asked for 5, I think, so we're going to go on to number 10. Okay, let's look at number 10. Okay. Do you guys remember what domain and range means? Domain is all the possible x values, and the range is all the possible y values. Okay, so of these kind of pictures, it always helps to draw a diagram. Okay, draw a diagram. Okay, so the domain, or like a graph, the domain is between 0 and 12. So basically my graph on the x, it only exists between 0 and 12. Basically, we only have service in this area. Will any x values go into the negatives? No. Will x values go beyond 12? No. So basically, my whole graph has to be between this boundary. Okay? The range of my graph is between -8 and 4. So that's the range. The y value has to stay between -8. So let's say this is -8. And 4. So this way, the biggest y value I ever have is 4. The smallest y value I ever have is 8. So that means my whole graph has to stay within this boundary. Does that make sense? So the domain is between 0 and 12. The range is between -8 and 4. Furthermore, they told us what? They told us that f of 3 equals -5. How can I plot that or map that on my graph? What does the 3 represent? The x. What does the -5 represent? The y. Do you guys get that? Because this is the input and this is the output. So when I input 3, the output is -5. That means there's a dot point there. Okay? Basically, this means that 3, -5 is a point on my graph. Okay? Also, when I input 7, I get 2. So those are 2 points on my graph. It's a function, so what do we know about functions? They pass the vertical line test, meaning that if I put a vertical line through the function, it will never do what? Never touch 2 points. Meaning I can't have another point here, and I can't have another point here. In other words, for every input, what happens? Only one output. If I input 3, can I have an output of -5 and an output of 4? No. If I input 7, can I have an output of 0? No, because I have an output of 2 already. Can I input like 5 and get an output of 2 again? Yes. Different inputs can have the same output, but for every one input, you should only get one output. If I put an A3 on the vending machine, I shouldn't get 2 things back. Oh, it's just like the vending machine. If I put A3, I should only get one thing back, right? Not like a Snickers bar and like a water. Okay, but on the vending machine, aren't there lots of options you can get to get Aquafina? It's not just A3, A4, A5. All of those inputs give you the same Aquafina output. You see what I'm saying? So on the vending machine, you could put different inputs and get the same output, because sometimes they have more than one slot for the same like candy bar or drink. But you can't put in one input and get 2 different foods. Otherwise, there's an error. It's not a real function, or it's out of function. Okay, so select each statement that must be what? That must be false. So don't be tricked. Don't pick all the ones that are true. Pick all the ones that are false. Okay? So f of -2 equals 1. Can I input -2 and get 1? Why not? The negative 2 is not part of the domain. Remember, all my x's have to be between 0 and 12. So that one is not part of the domain. So, that one has to be false. So that's the right answer, actually, right? What other ones are outside of the domain? 4, is that outside the domain? No, that's good. 5? Good. 7? Good. 10? Good. So the other ones are all good in terms of domain. Okay. So that one has to be false. F of 4. If I input 4, can I get negative 5? Yeah, I could input 4 and get negative 5. That's fine. So that's not false. Can I input 5 and get 6?
No.
Why not?
Because
It's past 4 and the highest part of my range is 4. So that's outside my range. So that has to be false. Is anything else outside my range? Negative 3, is that outside my range?
No.
That's fine. Is 2 outside my range? No, that's fine. Okay, let's see. 7, if I input 7, can I get negative 3?
Yeah.
Yeah? No, I cannot. Why not? Because 7 already has an output. It has 2. Can I get 2 and I put 7 and if I input 7 in the vending machine, will it give me 2 and negative 3?
No.
No, and it would not pass the vertical line test, so that cannot be. Can I input 10 and get 2? Yes.
Yeah.
So the only ones that have to be false are A, C, and D. Okay? Does that make sense? It's kind of tricky. You have to know domain and range, and you have to know stuff about being false. You have to remember that it's asking you for false, not true. Let me give you guys a hint now that you're here. What is the domain of this function? What kind of function is this? Piecewise, very good. What's the domain? Domain is the all possible what? X. So what do you guys think is the domain? Domain is the x's. How small can my x be? Right here, x can only go this far? Doesn't it keep going? Going forever. So it's from negative infinity. Okay. Can my x, for the x, I could just like think of a ruler or something. Okay, can my x, do I have service here? Yes, right? Even though it doesn't look like it, wouldn't this thing keep going down and it keeps going to the left? So do I have service here? Yes.
Yep.
What about at 4? Do I have service at 4?
Yep.
Where's my output at 4? Is it the bottom one or the top one?
Top one.
So it still exists though. Do I ever lose service?
No.
Okay, so I'm good at 4. Am I good after 4?
Yep.
Am I still good?
Yep.
Do I still have service?
Yep.
Is it bottom or top?
Bottom.
Okay. And now it's the top. And then do I have still service?
Yep.
And then
The top.
until 6. Okay, can I go after 6? Do I have any x values after 6? So my domain is going to be from negative infinity all the way to
Positive
6.
Yeah.
Is it closed bracket or open bracket?
Close bracket.
Okay. What if this was an open circle? Then would this be closed bracket or open bracket?
Open.
Open. Another way I could write it is my x has to be what?
Question, would it still be
X has to be
Less than or equal to
6.
6. Do I have to put a negative infinity?
No.
No, just less than 6 means all the way less
All
than
the
next
way
to
down.
all the way to infinity.
Yup.
you see how in the last little horizontal line, it's open and then it's closed at the end?
Yeah.
Would it still be a function if both of them are open?
Yes? Yes. Okay, what about my range? Let's start from the bottom. How low can my y go? All the way. And then do I have service here?
Yup. Yup, you got service.
All the way to where?
To the top.
To a positive infinity? No, right here, huh? So what if that is 7? Then what is my range from what?
Negative infinity to positive.
What if it's open here? Let's do it like that, okay? Open, or I could say y has to be what?
Less than or less than 7.
7. Or equal to? No, because it's open. Okay? All right, good job, guys. You will see something like that tomorrow. Okay, number 11 says, okay, this one is just a definition. Which of these are true? The graph of g is the graph of the equation y equals g of x. That's true. Okay, if I have a graph like this, and this is f of x, what I'm saying is my y, I'm graphing y equals f of x. So for any x, my y has to be the result of inputting x into my f. So this is true. The value of g of a is the output of g corresponding to the input a. If you input a, g of a is the output, right?
Yep.
So that's correct also. For any element x in the range, g of x represents an element in the domain. Is that true?
False.
No, the only thing that's wrong is what? For any element x in the domain, g of x represents an element in the range. Okay, the function g assigns each element of the domain exactly one element of the range.
Yep.
Yeah, remember you only have one out. That's exactly the definition of a function. So A, B, and D are correct. Okay? All right, let's look at number 14. Somebody asked about 14. Oh, good. All right, you will be asked to graph something like this on the test. Okay, the function is 1 minus the absolute value of x plus 2. So what's the parent function?
Absolute value.
And we know that looks like
On that curve.
a v, and it's like if you go up 1 over 1 over 1 up 1 over 1 up 1, it has a slope of 1 on this side and it has a slope of -1 on this side. Okay, so the slope of your v matters. If you do it like this, it's not going to be right. Okay, it has to be like this. Okay, now unless you multiply it, if I say y equals 2 times that, then the slope will change, right? But this is just a 1 in the front, right? Okay, so that's my parent graph. What happened to the parent graph? What does this do?
To the left.
No, this negative in front flips it. What does this do? Shifts it to the left. And what does that do? No.
Moves it down.
It moves it up. Okay, so let me rewrite this for you. You know why you guys got confused? It's not written the way you normally see it. Okay, this is the final exam, people. It's the same thing as this plus 1. Isn't it the same?
Yeah.
If I say 3 minus 2, isn't that the same thing as -2 plus 3?
Yeah.
Right?
So
Because it's plus negative, so it's 3 plus -2. You could just switch it to -2 plus 3. So really, what is the 1 positive or negative here? It's positive. What's negative? The absolute value. You see?
so you just switch sides.
Yeah. No, we didn't switch signs. The absolute value was negative. And the 1 was positive. It was positive. It was always positive.
Okay.
The minus was in front of the absolute value. So now the absolute value got flipped, and it got horizontally shifted, and then it shifted up. So which one do you guys want to do first? The flip. So if you flip it over which axis?
Wow.
Is it a vertical or horizontal shift? I mean flip.
It's a vertical.
It's a vertical flip, and you guys need to know this. If it's a vertical flip, does it flip over the x-axis or does it flip over the
Flip
y-axis?
over the x-axis.
If it's a vertical flip,
Y-axis.
then it flips over the x, even though it's vertical. Because look, if you're flipping this way, who are you jumping over? The x. If you're a horizontal flip, you're jumping over the y. Okay, so now we're going to flip it. Okay, and make sure you cross all your points still here, right? We flipped it, and then what do we do? Move it 2 to the, no, oh yeah, left, and 1 up. So I'm gonna move 2. I'm gonna start with my vertex. 2 to the left, 1, 2, and 1 up. 2 to the left, 1, 2, and 1 up. 2 to the left, 1, 2, and 1 up. Okay, you notice there's a pattern because it's still yeah, and then okay, so there's my final. Okay. All right, that was number 14. We only have a few minutes left. We're going to do 17, 20, 26, 7, and 8. All right. Thank you guys, those who did your homework over the weekend so that you could have specific questions. Well, not thank you, but good job. Good for you. At the end, if we have time. Okay, so here we are. This is, what's the parent graph? 17. Which of the following graphs shows a function of this form for some real number c? Okay, so what's the parent function here? Square root of x. But what happened? It shifts 4 to the right and
To the right 4.
up by c. Up or down, depending on if c is positive or negative, right?
Yeah.
So I just need to find a square root that shifts to the right. Okay, so is a shifted to the right? No. Is b shifted to the right? Yes, but how much?
2.
No, by 6.
That's demon.
Oh, sorry, D. All right, sorry. Oh, no. No.
7 hours.
Watch in the middle of. Okay, anyway, this one D shifted to the 6, so that's wrong. Okay, B is shifted 2 to the right. You're right, so that's not good. What about C? It shifted 4 to the right. How much did it go up? So how much is your C? 5, so that's good. Okay, what about E? It shifted how much to the right? 4. Did it shift up? No, so is that wrong? No. What can C be?
0. Yeah.
C is any real number, right? Including 0. C could have been 0. Okay, long as it shifted over 4. What about F? No. So your answers are C and E. You see how that's so tricky? You guys would have not put C. You put C only and then you get it wrong. Because don't forget, 0 is a number. Don't discriminate. Don't hate. Okay, number 20. Okay, now the graph of f of x and g of x. What is g of x? G of x is just f of x transformed plus k. What does the plus k do? It's a vertical up or down shift, right? It's shown. Okay, so which one's the original, f or g? F is the original. What is g? G is f after you've done what to it? Added k to it. Okay, so Vivian or Vikram claims that the value, hey, that's like a yoga. Vikram claims that the value of k is 6 since the x-intercept is 6 units to the right. So he says it's 6. Decide if Vikram is correct. Otherwise, give the value of k. What do you think happened from the original to the g? It shifted down 3? Okay, so pick any point, like this point. What happened? Did it move up or down? Down, how much?
3.
1, 2, 3. So what is k?
Negative 3.
-3. Okay, what was Vikram thinking? Vikram was looking at the y-intercept, and Vikram said, hey, look, the y-intercept moved that way, right?
Yeah.
So he wanted to say that the shift was 6, but is this supposed to be a vertical shift or horizontal shift?
Horizontal.
No.
Vertical.
Vertical. So that's why Vikram is wrong, because he was looking at the horizontal shift, not the vertical. Huh? Because f of x plus h or minus h, that's horizontal. F of x plus k, if it's outside the parentheses, that's vertical. If it's inside the parentheses, that's horizontal. Okay? All right, now let's look at 26, 7, and 8. I hope everything else you guys are crystal clear. Okay, the central angle. Okay, this is you're going to be on your retake today too, guys, at lunch. Okay, the central angle drawn on a unit circle. A unit circle is just a circle with radius 1. Okay, and the central angle we learn in geometry has a center at the origin, or just starts at the middle of the circle, and has 108 degrees. So 108, maybe it's like this, right? 108 degrees. They want to know how can you transform this into radians that looks like this, k pi. So we're just converting degrees into radians. So when I convert, this is what I do. I multiply it by a factor of 1. I want my degrees on the bottom so I could cancel out the degrees. How many radians equals how many degrees? Pi radians equals 180. Okay, so if I multiply across, what's going to cancel? My degrees will cancel, my radians will be left. 108 pi divided by 180 radians. That's my answer, but if you simplify that fraction, you should be able to simplify that after some extensive work. Your answer is 3 pi over 5 radians. But how come for my k I only put 3 over 5? Because they asked you, what is the value of k? The radian measure of this angle can be written as k times pi. If my pi is already here, what does k have to be to make this true?
3 over 5.
3 over 5. So that's why you put k equals 3 over 5. Get it?
Yeah.
If I ask it to you like this, if I just ask you for radians, you have to leave the pi there. Do you get the difference? If I ask you for what is a radians, you say 3 pi over 5. If I say what is k, then you give me 3 over 5. Because on the test, it might not be like this, so read carefully. Okay, find the radian measure. If we want to convert 372 degrees, same thing. So you're going to do radians over degrees, multiply it by pi over 180. The degrees cancel, and so you're going to get 372 pi over 180. And you just have to reduce that. If you divide that by 45, apparently,
4 and
then it's going to be 7 pi over 4. Yes? Yes, Anna? At the end, okay, because I already have these requests, if I have time. Find the degree measure of 7 pi over 4. How do I convert the other way? 7 pi divided by 4 radians. I want to multiply by what? Degree over radians. How many degrees? 180. Do you guys see why I do degree over radian this time? Because I want my radians to cancel out. So my degrees is going to be, oh look, the pi's cancel out too. So it's going to be 7 times 180 divided by 4. I don't want to waste time doing 7 times 180 when I have to divide by 4 anyway. What's 180 divided by 4? 45. Because 80 divided by 2 is 90. Okay, so 45 times 7 is 315 degrees. Okay? Alright. And 28, and then we'll take Anna and Yumi's request. 28. What doesn't make sense? Oh shoot. You're right.
Somewhere in the line. You know what? I think the top one is wrong. I think you just pulled that.
Oh, I did. Thank you. Yeah, I was just looking at this. I thought this was the answer. Yeah, I just reduced that. You guys know how to do that, right? Okay, good. Alright, so number 28. Well, you know how to do that, right? You just have to, they're both divisible by 2 at least. No, they're both divisible by 4, so divide by 4, right? Okay. Alright. Alright. You guys, what kind of triangle is this? This is a 30, 60, 90 triangle. Okay? So 30, 60, 90 triangle, we know that this would, if this was x, then this would be 2x, and this would be x rad 3. So if they want you to find x is half of the hypotenuse. So what's half of 17?
Like
8.5. Okay? So you have to recognize it's a 30, 60, 90 triangle. Okay? Really simple. And if I asked you for this side, it would just be 8.5 times rad 3. Okay? Alright, Anna, which one was it? 23. Yumi, which one was it? 36. 23 and then 36. Okay, finding the inverse. Okay, so what is the inverse of 4x minus 8? Let's try it. X plus 8 equals 4y, divided by 4 on both sides, so y equals x over 4 plus 2. You get me? But they want that to equal 1/4 x plus k. Okay, is 1/4 x the same thing as x over 4? Yeah.
Yeah.
So what does the k have to be? 2. Okay? You have to recognize that this is the same thing. Oh, where did I get the 2 from?
Yeah.
Because if I divide x by 4, it's 1/4 x. If I divide by 8 by 4, right? So basically what I did is I divided by 4 on both sides, and so you have to distribute that to both. Okay? Yeah? Okay, Yumi, which one? 36? Again, if you have 2 retakes to do at lunch today, you need to come speak to me if you need more time, or so that you could maybe come at a different period. Okay, this is a good one. So area equals 1/2 height times b1 plus b2. They ask you to solve for b2. We know how to do this. What do I have to undo first? Not the parentheses. I have to do the last thing first. So how can I get rid of this? These guys. Multiply by 2 on both sides. If I multiply 2 on both sides, I get 2a equals h times b1 plus b2, right? Because the 2 and the 1/2, they cancel out. I have to divide by h. Okay, so b1 plus b2 equals 2a over h. I want to get b2 by itself, right? So what should I do? Subtract b1 on both sides. Man, I should put this problem on the test. It's so cool. So b2 equals 2a over h minus b1. That's easy, right? So the answer is? It says select all that apply. Oh, they didn't say to solve for b2. They want you to solve for any of them. Like whichever one is correct. Wait. Anyway, alright, I'll see you at lunch if you have a retake. Otherwise, I'll see you tomorrow with your calculator for the final. Good luck. I'll put this online.